like fix all the details. But if it can be done, then a lot of help will be possible. I think, because if the quiz can be done online. So yeah, so one thing is very fast thing that we are trying to figure out is that nobody is able to take any inappropriate manners solving the question, like mm, copying, exam copying or anything. So that is one very important issue. There is yes, and after that obviously that how the internet connection is. It is poor, is it good? That is one issue. Yeah, so I hope yeah, there will be some glitches. I know. I mean, there may be a little number of glitches, but yeah, we have to figure it out, and for that only it is taking this much time and these many rounds of preparatory mocks. So we also before I think the group leaders gave, we also gave the exam like that. So yeah, I hope it will be fine. Just see how it pans out.
Yes, sir.
Yeah. Okay. So Rahul Kumar is there. Pranit is there. Hi Rahul. Uh, you guys have any questions from week three? Rahul, Pranit. So I hope yeah, we were talking with Sudhiti for about the exam, quiz one exam. So mm, please be prepared. Start preparing for quiz one. It will come very soon, most probably. As Sudhiti was telling, the group leaders have given a mock exam till now. So let's see how the thing pans out.
I have no queries. Just
Yeah,
when will this session start?
yeah, it has already started. Okay, can you hear me?
Yeah, yeah, I can hear you.
Yeah, yeah, sure. So Pranit, everything is ready for week. I mean quiz one, right? I mean the uh, so the most scoring part will be this week two and week three, I think, for all of you. So all the formulae, all everything are uh, ready, right? Anything from week to week three you want to discuss?
Can you like this is I mean brief all topics so that it will be like revision test
Yeah, yeah,
and
sure, sure, sure. We'll just ask other two guys if they also have any doubts. So you can ping us in the chat window if you have any questions. So this is basically for week three activity questions, but as we are near almost at the end part, and so quiz three, sorry, quiz one will also come up sometime. So soon. So that's why maybe week two, week three, and sometimes some things of week one also we can try to revisit once. Uh, I'll revisit as Praneeth was telling. We will do some parts of uh, brief, redoing of week two and week three. So after that, we'll see if some activity questions can be solved or yeah, something else. Um, yeah, so we had the Cartesian coordinates and in week two. So we and yeah, Cartesian coordinate system. So which specifies each point in a plane by a set of numerical coordinates. So now these coordinates are sign distances. So we have the rectangular coordinate. After that, we will talk about there are other coordinates also, coordinate systems also, right? So there is I think spherical coordinate system, rectangular coordinate system, all are there. But in this program, till now, we are talking about rectangular coordinate system only. So rectangular coordinate system was established by Rene Descartes and some of his other um, some of the other people who were working on this topic at this point, that point of time, maybe around the early 19th century or something. Have to check the timeline. But so Rene Descartes started discussing about the coordinate geometry with the coordinate system at first. So that's why the coordinate system is rectangular coordinate system is also called Cartesian coordinate system. Uh, we have the four quadrants, as we all know. So first quadrant uh, is in the, you see the distance screen. So this is the first quadrant. You can see my mouse pointer. So here the x-axis numbers are all positive. Um, the x-axis is also has also another name called abscissa, but that is not that much important. So in x-axis we have the positive numbers, y-axis also, which is also called ordinate. There also we have some positive numbers. So both the x-axis and y-axis is positive. Similarly, we have the second quadrant where the x-axis values are negative and the coordinate, that is the y-axis values, they are positive. So that will be this side. This side means the all the x-axis values of the abscissa values, they are negative. -2, -4, -3, -5, -7, -6. So all are in negative numbers. And we have the ordinate, that is the y values, that is 1, 2, 3, 4, all are positive. So y values positive, x values negative, that is in the second quadrant, right? Then we have third quadrant. Third quadrant is both negative, both the x-axis value and the y-axis value is negative. So that is the third quadrant. Third quadrant has this is this one. So here you can see -1, -2, -3, 4, 5, 6, 7. Or if you want to go even in the fractions, -1.5, -2.5, 3.5, everything. And the uh, ordinate values, that is the y-axis values, those are also in negative. So -0.5, -1, -1.5, -2, -2.5, -3, -3.5, etc. Okay. So we have in the third quadrant the all negative values. So basically, if the x-axis value is given of a point, the x-axis value is given as negative, y-axis value is given as negative, then it is a third quadrant. So suppose if I give 2, 3 points, say I give you 1, -2. Can you tell me which quadrant this will be? Anyone? It's a very easy thing. You can write in the chat box also. Suppose we give 2, 3 points. 1, -2. Then suppose -2, 1. There can be -2, -2, and we can have 1, 1. So these are few of the values, and you can see it is actually making a square. It's like making a square. No, it is This making us there. So we can connect them and see that they are connecting at this point. So this is the meet point, you can see. So anyway, so this is the basic coordinate system. So the first quadrant, this side is the first quadrant, this side is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay. So apart from that, what we have here is the how to calculate. So the week 2, week 3 is basically the formulae, most of the formulae, whatever is there, and a few concepts of slope. So I mean, not even few concepts, one or two concepts of slope. So distance between any 2 points, how to calculate that, as we all know from our, I think from mechanics or wherever we have studied, that how to calculate the distance between any 2 points. So if it is, say, 2 points are x1, y1 and x2, y2, then root over x2 minus x1 whole square plus y2 minus y1 whole square. That we already have understood. Also, we have an area of the triangle. Area of the triangle is formed by 3 points, and so we can have different conditions of, you know, collinearity from the triangle. So what I know is that if the area of the triangle is 0, right, then the consisting of these 3 points, the 3 points which make a triangle, and those, if the area inside this triangle is 0, then the 3 points are collinear, right? So that is also can be obtained with this formula, delta equals to half of mod x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, so now how do we remember this at the exam time is that you see, I mean, it is going like a circle, right? I mean, so 1, then the inside is 2, 3, then 2, 3 and 1. Then with x3 is y1 and y2. So, I mean, what I mean is, it will be very easy for you, but you may just. So, I mean, it is going like 1, 2, 3, right? It's going like a circle. X1, then y2 minus y3 plus the next thing is 2, right? So x2, y3 minus y1. So as you most probably know that this whole concept, whole formula comes from the matrix calculation, which you will again learn in the maths 2, which is coming next. Anyway, so plus x3, which is, sorry, x3 into y1, again this circle form y1 minus y2. Okay, so there are most probably other shortcut techniques also, but at this point, yeah, we have not I mean, given any kind of shortcut techniques. This will be fine, we hope. We think so. So that is one concept, the area of the triangle, that will be important. uh, can you hold a minute, just a minute? There is so other than that, we have the section formula. Section formula, what we have is, if a point internally cuts the line segment which connects 2 points x1 y1 and x2 y2 in a ratio m is to n, then the value of x and y will be what and so there can be, so the diagram looks like this. We have A and B. So the point A has coordinate x1 comma y1. The point B has a coordinate x2 comma y2, and the point P has a coordinate x comma y. Now the ratio is m and n. Okay. So one question is if it is given like one ratio is given in the problem, that if it is 1:3, then how do we know which one is m and which one is n? So basically, as far as I understood, I mean, we will give you the either if it is an MSQ, both the options will be given. So if m and n, I am telling that if it is given 1:3, how do we understand that one is m and which one is m and which one is n, right? So m equals to 1 or n equals to 1. So in that case, what we can do is we can give you the both the value options. I mean answers which come from taking both the values. If it is an MSQ, multiple select, so more than one option is correct. If it is an MCQ, so only one correct option will be given. The other correct option will not be given in the, generally it is not given in the option. So what context can we use? Uh, so it looks like a thread can be cut at one point. That is one context we can understand. What other thing? So it can be a beam which is broken at one point. Okay. It can be a rope which is also cut. What other context we can use it is maybe a road is we are dropping pitch on a road. So maybe I mean it is this concrete they deposit on the not concrete, I think pitch on, yeah. So they deposit on the road. So maybe in one how much portion of the road is I mean made with pitch and how much is left. That can be one context. What other can be there is maybe there can be different things which you can think of. I have to, on the top of my head, these are the things which is coming to me. What else can we think about is mm, maybe a ribbon has to be colored. So one portion needs to be colored, another portion needs to be another color. So from there, if 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 the amount of if the cost which is required to calculate which is required to paint 1 unit distance of the ribbon is given, then how much is the cost required to you know paint the m part, this m portion, this part from A to P, how much portion is it? So those you understand, right? So those are the contexts which can be given. Uh, Apart from that, I think so. It should be a straight line. It is not broken. Then there is a. I mean, it is not bent at the point when we are while we are giving the question. Uh, as far as that's what I think, it is generally either cut so that the angle in between AP and EB is not, I mean, changing from 180 degree. That is what we are thinking. Because it is a straight line, right? AB is a straight line. What else can be given? Yeah, so those are the things, I think. There is another thing called external cutting of the line segment, external section. So that is a little, I mean, difficult to, you know, visualize. So maybe, so what we want to say is that our line is here, like A is x1 y1 and B is x2 y2, obviously. Then so we have another point which is collinear with the first 2 points. Okay, then its coordinate we have to find out, and the ratio between the uh, A to P, that is the this portion A to P is given and B to P is also given. So if that is the case, then what is the coordinate of x and y? Also, so that can be asked, what is the coordinate? Also, the other thing can be asked, that is m and n. So if x, y is given, all the three coordinates are given, right? Coordinate of A, coordinates of B, coordinates of P, all are given. In that case, what is the m and n value? So that also can be one question. So till now, what do you think? So is that okay? What do you say, guys? You can switch on your microphone and you can talk. I mean, it's very less people, so we can talk like a small group of friends. Anything you want to say up to now? What I was telling till now? Okay. Yes, just let me know. Yeah,
No, sir. Please
yeah,
continue.
yeah. I mean, you want to tell anything? That's also fine. Love to have a two-way discussion also. So anyway, what I was talking is about
Sir, there will be some tricky way of saying questions. No, sir. Why don't you cover that type of
uh,
like
tricky means
misleading words, something like that?
misleading words means
From top side of the means considering from this side like that.
um, okay. I'll misleading words. So we generally try not to give. Okay. So if you can give me a text, I can maybe discuss. If you have a sample question or something, uh, you can give that. Otherwise, maybe we'll go to the practice assignment solution and we can see the questions from there. Okay, will that be okay? Otherwise, you can send in the chat box. Yeah, sure. I mean, we will discuss. So if you have any particular question you're thinking of, send us in the chat box. Otherwise, we maybe we'll have a uh, we'll see some of the questions from the practice solution. They may help you to understand the if it is some misleading words. Okay. So apart from that, what we have is so these are the external cutting. So so after that, what we are having is the concepts of straight line. Yeah. So I was just discussing about section formula. So there are two kinds of section, Vishal. So one is internal section and another is external section. So there are two formulae, as we know. So for internal section, we have the x coordinate and y coordinate. That is the mx2 plus mx1 divided by m plus n. So we were discussing is what are the contexts this can be given, right? So if we are so this is the internal section. Here what is happening is that there is a line AB and one point P is cutting the AB line in m is to n ratio. Okay, so the point P has a coordinate x comma y, and the point A has a coordinate x1 y1. The point B has a coordinate x2 y. Okay, now from here the formula gives us that x equals to the, as we know, mx2 plus nx1 by m plus n and my2 plus my1 by m plus n. Now I was talking about the different contexts which can be given. So one is that I was talking about a rope or a thread which can be cut at one point, okay, or maybe at two. no, I think 1 point is fine, and then maybe the point which is so after we cut at 1 point, maybe this, suppose we cut the point PB, then we can cut it in another ratio, another two ratios. That is also possible. So one, what we can do is we can have a rope or a thread which is cut. We can have a context of a road which is at some portion there is pitch is, it is pitched. I mean the pitch is deposited at some point, and the other portion of the road is not completely repaired yet. Okay, so that we can understand, that we can calculate. There can be another context of a unit wide, distance wide ribbon, which can be, you know, painted, and the cost of painting for unit distance is given, and from there we have to paint one portion, say AP, in one color, say red color, and the BP portion in another color. Okay, so in that case, what will be the cost? There can be a question like that. Okay, so those are the few things. What else can be there is that yeah, I mean from internal section, though, that is till now the only thing which I understand, which I can think of. Anyway, so that is the internal section. About external section, what we have is that it is a little difficult to visualize. So what we have is, if there is one line segment, one line given AB, and another point is there called P, which is collinear with the line, but it is at a, you know, at an outward distance from the given line. So it is collinear, but exactly not on the line. So, and in that case, if we are given the in and in ratio, okay, which is shown here, A to P is the M value and B to P is the N value. So in that case, how do we calculate? Okay, so from here also what we have here is that x equals to mx2 minus nx1 by m minus n, y equals to my2 minus my1 divided by m minus n. This formula is given. So basically you have to utilize. So can you think of any contexts which this can be given? So maybe the pitch thing, we can say that up to here we have made one road, and from A to B, and we have to make a road up to A to P, this xy and x1 y1. In that case, whether how much is the ratio of the road yet to be made, or how much portion. So in that case, it will be how much portion is n divided by m plus n, right? N divided by m, sorry, not m plus n, n divided by m. So that is one possible question. Not many others I can think of. You can think of different questions. What else can be made is that some sun ray can be given, no, some light. So maybe a laser beam. Suppose a laser beam goes this much distance at x minute, A to B distance at x minute, and so how much time it is taking to cover the BP or something like that. Maybe, I mean, with this formula, whatever we can think of. Okay, but we have to remember that all the 3 points are collinear. Okay, so that we have to like keep constant, whatever questions we have developed. After that, we start with straight line, and eventually we discuss straight line in week 3 as well. So in new structure, so up to here we are, I mean, up to this quiz we are um studying week 2 some portion and week 3 some other remaining portions of straight line. So but in the next season when we are offering the course, we are I mean, this is not required, but anyway we are we will be merging, so week 2 week 3, so that all the straight lines are together and nothing is skewed. So anyway, straight line, the equation of a straight line is in 2 dimension. The equation, yeah, so there can be straight lines parallel to y-axis. There can be straight lines parallel to x-axis. So if you see the different slopes of straight line, so if I Wikipedia, just a moment, now Wikipedia slope. So there was a few. So if you guys can see my screen, it is a slope of a line in coordinate system. So you see that it is how this is the equation of the line, and this is the exact line, and this is the coordinate system. So what it shows here is that how with change in the slope value, the uh, the line shape is changing. Okay, Vishal, so what are the topics? Can you write in the chat box? Or I mean, this was for week 3. So what are the topics you can write in the chat box? Okay, if possible, we'll discuss. Okay. Uh, so anyway, what we have here is that yeah. So if we have the slope of x to be increasing in positive direction, then the line moves from the first quadrant towards the second quadrant. Yeah. Okay. Functions and yeah. Yeah. So Vishal, what are the questions of functions? Maybe if you just tell us a bit in the, yeah, say it's in the chat box. And if we are increasing the, if we are again increasing the, sorry, if we are reducing the slope, okay, so from -6 to -2 or something, then it will again be in the second quadrant to third quadrant or fourth quadrant, something like that. So that is the concept of slope, and slope actually is measured in this way. So from x-axis, positive x-axis towards the direction of the line, right? Uh, so that is that, and so there are concepts of straight lines called, I mean, different. So one is slope, basics. Okay, sure. Because Vishal, we'll try. We'll try. Yeah, sure. Why not? Just let me go through. Someone was telling to go through the topics of week 3. I'll come after that. Okay, sure. So the main equation is always y equals to mx plus c. So if you see, I mean, now if you know where we will use these equations, right? So if we use a linear regression or in the algorithms in machine learning, okay, so there we have mostly linear regression. We are going to use the straight line equation. Mostly the equation which is going to the form which is going to be useful is y equals to mx plus c, but there are other functions as well, other forms of the equation which actually is given in the week 3. So the form y equals to mx plus c, that is actually called the slope intercept form. Okay. So the slope intercept form is the one slope is given, that is m, and another slope is given, the y-intercept is given, that is like the c. Okay, so c is the y-intercept and m is the slope of the equation, straight line equation. The general form is actually different, a little different. So it is shown with this one, this representation form. ax plus by plus c equals to 0. There are different other forms. So one is slope point form, where the slope of the line is given and one point is given, one point of the line is given. There are point form or 2-point form. So they were actually uh, coordinates of 2 points, two connecting points are given, and we have to calculate the equation. There are intercept form, or as both are intercepts, so intercept form it is called, where the y-intercept and x-intercept both are given. So if a is the x-intercept and b is the y-intercept, then x by a plus y by b equals to 1. So that is basically the equations of straight line. Other topics are there. So also here's what is slope. So slope was to describe both the steepness and the direction of a line. So the slope is represented with m. Why? Although it is represented with m, nobody knows. I think someone, yeah, first started, some mathematician started it, and then yeah, just the notation carried forward, was carried. So anyway, y2 minus y1 by x2 minus x1. That is the distance of the y coordinate divided by the distance of the x coordinate. That is our slope. And that is actually given by tan theta. So not much of the tan theta part will be required. We are not teaching trigonometry. So those concepts are not very much required. But if you can learn, I mean, it will not be required, but if you know the basics or basic values, what is sin 30, what is cos 30, that may be helpful later. For quiz one, I don't think it will that much be required, but still, for being in a safe side, just you can check the tables. Theta is the inclination of the line with respect to the x-axis. So then we have the perpendicular nature and the parallel nature of the two parallel straight lines. So when we conditions of two lines being parallel, when they will be parallel is that if their slopes are equal, then they are parallel. When the two lines are perpendicular, only if their product of the slopes are equals to minus. So so what are the questions you can think of from here? So we have this thing that two lines are parallel if their slopes are equal. Two lines are perpendicular if their product of their slopes are minus. So see what will happen in quiz one is that we will give you so in graded questions, or sometimes in graded questions also, what happens is that what we give is that you have to solve the questions which are from both weeks, one or more than 1 week. So we can give a combination of week 1, week 2. So we can give a combination of week 1, week 3. So there are say parallel lines. Can have parallel lines, right? So we can have y equals to say 2x. We can have y equals to 2x plus 5. We can have y equals to 2x plus 7. Is it between, right? This will give it a red color. So these are parallel lines, all parallel, right? Y equals to 2x plus maybe 3. All of these are parallel lines. So if you say that this one is the first line is, maybe we will just change the color, that will be better. Red, blue, green. So if you think that these are all members of a set, These can be all members of a set, right? Because all of them are parallel lines. Okay. Now, we can have, you have say y equals to, what is the perpendicular line? Can anyone tell me what is the perpendicular line of any of these things? What will be the slope? What do you guys think? Hmm. See, this is again a perpendicular line, and it is you understand, right? This is there is no coefficient y coefficient. Sorry, yeah, y intercept. So that's why there is no. So it is passing through origin. If I put y plus 1.5x plus 3, it is not passing through origin, right? So if we put plus p and we give a slider, we can actually see how the line actually behaves. So the thing is, we can give you one set of the parallel lines. We can give you set of perpendicular lines, and we can ask you the interrelation in between those two. That should be fine, right? You know what is the set, you know what is the cardinality, you know what is the perpendicular lines, you know what is the parallel lines, and all those you can understand. Maybe I'm just thinking the top of it. So anyway, uh, all that done and see we have the, yeah, as I was talking, we have 2 point straight line and different forms of straight line. So distance of a point from a straight line, that is important. So if we have say if we draw maybe 0 0. Okay. So in that case, what will be the distance of this line from this point? So you can see the distance is actually changing once it is moving fast and I mean it is going upward and downward. So from first quadrant and third quadrant, the distance is changing. So that we can calculate from the formula. What is the current distance? We can calculate from the general form of the straight line, which is ax plus by plus c equals to 0. That we can give from the distance of a point x1, y1. So ax1 plus by1 plus c divided by root over a square plus b square. That is the intercepts, the root over the square of the intercepts, right? And the distance in between two parallel lines also can be calculated from their intercept, the difference of their intercepts. So ax plus by plus 1 equals to 0 and ax plus by plus c equals to 0. So there can be different questions which can be formed from here. Lot of things. So maybe like distance between two parallel lines. So it will be distance between two parallel lines. Maybe one road. So what is the distance of a road? Maybe the equation of two sides of the road is given. The two sides of a river is given. What is the width of the river? That we can calculate. All those things can be done. And maybe like so maybe it is not very it's a very complicated thing, but suppose two particles are moving in a parallel path, okay, and so if they, what will be the parallel distance, what will be the distance in between those two particles, right? So then it will be if a particular distance is crossed, if they come particular distance, the parallel, then there will be a light signal. So whether the light signal will be on or not. That is some those kind of questions you can form. Okay, so maybe not even one parallel line, one set of parallel lines, maybe 2, 3 sets of parallel lines. Just I mean idea. And all of this we can combine with the week 2 and week 3, right? So if there is a two parallel lines, and then maybe one of the parallel lines is actually an edge of a triangle, okay, and then we can calculate the triangle parameters from that parallel line distance or something like that. We can think, right? Um, Apart from that, the another concept which is there is called SSE. SSE is the sum of squares. SSE is used when there are different data sets, experimental data sets, and we are talking about taking a best fitting option. So if you go for experimental physics or any experimental topic experiment, you will see that none of the experimentally obtained data sets do not follow the mathematical formula you see here. Okay, I mean, if it follows, then it is basically not good. Yeah, then it is not very truthful experiment. But anyway, so if it is, so we have basically the sum squared error. What we have is the sum square error or different types of error value calculation. If the error value is less, if the sum square error value is less for whichever line is given, then we have the best fit. Okay, for that line we have the best fit. So if two lines are given, which will most probably be given to you, 2 3 lines, and you have or 4 lines. Okay, I mean those any number of lines, 2 3 4 5, but we will see that you can handle the calculation. It is taking count of your time. Okay, so you will be given maybe 4 5 sets of equation, and there will be a table x value and y value corresponding, and then you have to calculate the SSE for both the so am I audible, guys? Thank you. So yeah, sorry, there was some issue with the, so it is actually raining in Chennai. So we are, so anything you guys want to say about SSE tip now, because just don't miss that. There is a good chance there will be question from SSE or straight line form. So these two topics are there: functions, sets, relations, straight lines. So straight line is the most scoring topic, right? Anything you want to talk about, or else we'll go on the later. Basically, you calculations will not be a problem. I hope. I think so, because the numbers, although it will be different for each of you, I think. Okay, in that case, it will be, but I think that the calculation will be easier. I mean, easy, not much difficult. Anyway, you will have the calculator, right? So you have to find the SSE for different equations, and you have to understand the best fit. So what is the best fit? You already know that you know what is the best fitting line, that the SSE is the lowest, and with that I think you will be able to solve the questions. So I mean yeah, that's that, and already we have the coordinate geometry, so should be fine if you guys are okay with all the formula. Um, Apart from that, so yeah, by minimizing SSC. Acha. Now we were talking about the week one. So I think Vishal was asking about week one. Um, so Vishal will try to discuss whatever possible. If anything else is there, you just ask us in the discourse also. Okay. If something is required, we will discuss there also. Everything may not be possible because this is actually a session for week 3. So we'll try to answer. So you can switch on your microphone. I mean, what is the exact thing, any particular question you wanted to know? Is it? Can you tell me?
Yes, I can hear you.
Yeah, I mean, can you tell me, I mean, what was the exact, is there any particular problem you wanted to discuss or something?
Yes, sir. Like in function, I am able to solve the questions
Okay.
from starting. Uh, I have mug up few formulas for the function, and from them I am able to solve the questions. But the basics of function I didn't know. So I want to know the basics of function, like some nuances, or from where this is originated and how it can be used in various forms of mathematics.
Okay. Okay,
Yes.
we'll try to clarify. Huh? Let us see. I mean, I also don't know what is there in the functions. That also is. So function is basically yes. See, this is actually a block diagram. I mean, you can see this is a block diagram of the function. So you can say that this is a machine kind of thing, a block kind of thing. That if you give a certain input, it gives a certain output. Okay. So only one output. For each input, it yields a corresponding output. Right? For each input, there will be an output. So if you have given an input, the function takes the input and gives an output of the output corresponding. Okay. So let us see what is the next diagram. Yeah. So the function actually connects the values from one set to another. Right? So uh, the first set of the values, it is called domain. So function is generally a binary relation between two sets. Okay. It associates to each element of the first set exactly one element of the second set. So function is basically a relation in between two sets. Now sets can be represented with that circle or the Venn diagram, right? So a function is basically relation in between two sets, and for each of the values in the first set, it associates exactly one at the second set. Uh, So if we draw a diagram, it sometimes looks like this. Suppose we have, I'll try to draw. Sorry, it does not look good. Anyway, so suppose we have, this is called, this is set 1, and the other one, suppose this is set 2. Now, we have a few numbers. Let us put 1, 2, 3, 4, 5, minus 1, minus 2. These are our set, first input sets. We can say this is the input sets. Now, function is basically a process. If you have written the understood, seen the computational thinking course, one input goes like this, then it decides, and then it gives to another one. So basically, what function does is that, so this is not actually a function, so this is a decision. This is not a good example. So what function does is, function is a block diagram. Function is a block, you see, not a block diagram. So if there is a, if, I was showing that diagram, you give an input, say x, it will give you an output, f of x. So here, what we have is 1. So we put the function here to this output, all possible outputs. Output, all possible output.
Excuse me, sir.
Yeah, sure.
So I'm unable to see the screen.
Oh, sorry. Sorry. I'll redo it. Yeah, so I'll tell it from here. Just keep going. So just you can see my the OneNote screen now, right? Vishal?
Yes, sir.
Yeah, you can see my OneNote screen, right?
Yes, sir.
Yeah, so we are thinking of two sets. What function does is it forms a relation between two sets. Okay, so the green color one is our input set. The black color one is our output set. So output set means all possible outputs. All possible outputs. Okay. Now, what function is? Function is a block, basically a block diagram. If you consider, so it is such a block so that it does a mathematical operation or any kind of operation on a given input. So if you give an input of, say, this x value, any value to the function. So this is our function f. So it will automatically generate you an output. So if you give an input to be x, it will automatically give you fx. All that is said and done. Now let us suppose in this case we have given some numbers in the input 1, 2, 3, 4, 5, minus 1, minus 2, etc. And we have defined this block or as the function. So what does this function do? So let us suppose that we give if equals to input square. So that means if of input equals to input square, right? Or what we can say is that if we give the input to x, then if x equals to x square, so if x equals to x square, that is our function. Now we can have the outputs in the black oval. So we have 1, 4, 9, 16, 25. Minus 1 square is 1. Again 4. So maybe we have minus 1, minus 4, minus 5, minus 7, minus 9, pi, e, all these numbers. Okay. Now, what does that mean? That means that we have our outputs in this oval, but we have some more other numbers. So what are the output numbers that we have, what that we require? So we have 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. Now minus 1 square, again this plus 1 only, minus 2 is 4 only. Okay, all the other numbers, those are not required. So what are not required? This minus 7 not required, e not required, pi not required, minus 1 not required, minus 2 not required, 5 minus 5 not required, minus 9 not required. Other numbers were required. So what are the required numbers? This minus 1 was required, plus 1 was required, plus 9, plus 16, plus 25. Now this set 2, there are mathematicians have given these sets names. So the first set, which was the input set, that is called, do you know what that is called, Vishal? That is called?
Yes, sir.
Yeah, please tell me.
So input set is a domain.
Domain. So what is this set 2 called? All possible outputs?
Sir, it is called range.
No, that is called codomain.
Codomain.
Now from here, if we take those sky colored highlight values, which are exact outputs of the input set, let us say we draw another oval, a small one, and we give there 1, 4, 9, 16, and 12. Those only. Nothing else, nothing extra. Just whatever output the function is actually taking. Whatever output function is actually giving, that set is called range. Set is called range. So range is this set. Okay, 7 minus 7 will not be there. This set is the range. So if we clear everything, now Sorry. So what we can see is that this range is inside the Venn diagram of the O domain, right? So three things can happen. Two things can happen actually. So one thing which can happen is that the range is equal to codomain, which actually will look like this. That suppose this is one range, and the same is so this is also this is the same, we hope. And sorry, my drawing is wrong. This is one, and another one. So these two are same, is what we can what we can think of maybe. Okay, sorry. So if the range is same as the codomain, that means codomain has only the values included in range, and nothing else, then it is called surjective function. If the codomain is same as the range. Okay.
Yes, sir.
And it cannot be true for all the cases. Like here, in this case, this is not a surjective function, right? Because here, range, here, range is not same as
Codomain.
codomain. So these are three terms: domain, codomain, range. Okay, that is clear. Now, what else we have? Yeah, so domain is the input set. Codomain is the set of all possible outputs. Range is the actual values from the codomain that the function can take. So, the mathematical definition is function is a process or a relation that associates each element from a domain to a single element of another domain. Okay? Which is called the codomain of the function. Now there is a good question that what is the relation? What is the difference between a relation and a function? Okay, so the fast clear-cut answer is every relation is not a function, but all the functions are relations. So function is basically a subset of the relations. Relation means, so a relation is actually a subset of the Cartesian products. Okay, so Cartesian products, we know that the set of ordered pairs. So a binary relation is a subset of the Cartesian product. Now, a function is a binary relation, but there is an added condition that for each element of the first set, there will be exactly one element from the second set. So, like 1, 1, 2, 1, 3, 1 is not possible. Suppose what I want to say is a function like, sorry, 1, 1, 2, 1, 3, 1, 2, 2. This thing, sorry, it is a relation, not a function. Why? Because we cannot think of a case, a function whose domain has 1, 2, 3, and the range will have only one value called 1. This is not a function. But if we have 1, 1, 2, 2, yeah, 3, 3, that can be a function. But there can be some cases where we have to actually check for the exact one condition, that is for the square values and all, that will check. But apart from that, so every function, every relation is not a function, whereas every function is actually a relation. Okay. So there are different functions are basically restricted versions of relations. Apart from that, there are 2, 3 things. One is the injective, surjective, and bijective function. Those are the types of the function. So there are different types of the function, and there are different names. So one is injective. So it is also called 1 to 1. There is also surjective function, which we saw. The another name of surjective function is onto function. And if a function is both injective and surjective, then then it is called, what is it called? Do you know? Bijective function. Okay.
Okay, sir.
So we have surjective and bijective we were talking about. So only thing left is injective. Sorry. So injective is also called 1 to 1 function. So if you can see my slide, so different inputs for injective function produces different output, or each element of the domain is mapped to an unique element of the domain. So basically, if you have how to say? Basically, that is that the different input produces different output. So if the function is fx, if basically, and you have two input variables x and y, then if x is not equals to y, then fx also will not be equal to y. So if x is equal to x, the same value, then only fx values will be same. Fx will be equals to x1, f of x, f of y. So if the input is same, then the output is always same. If the input is different, then the output can never be same. That is the injective function. So how to check an injective function? The process is very easy. That if a function is injective, then what you have to do is you put two variables, f of x equals to f of y. So if you have 3x plus 5, then what you have is, if you put say two numbers a and b. So suppose we have the function f of x equals to 2x plus 3. Now how do we check that this is whether this is an injective function? Listen. So what we do is we take two variables. Let us say a and b, and we put f of a. We just impose that f of a equals to f of b. We assume this. So if f of a equals to f of b, then what happens is that 2a plus 3. We are just putting the function here. So equals to 2b plus 3. So if we subtract 3 from both sides, 2a equals to 2b, or a equals to b. If so, that is the way to get to check for injective. Okay. So if your f of a equals to f of b, then you have found that a equals to b. So if this happens, then it is an injective function. Now I forgot whether I have any example of a non-injective function there. Yeah. So x squared is not an injective function. Why? Because suppose we put fx equals to x squared. So this is injective. F of x equals to x. Fine. So what we put is a square equals to b square. Same way f of a equals to f of b square. Now if a square equals to b square, then a square minus b square equals to 0, or a plus b equals to 0, or a minus b equals to 0. Either can either can it happen that a is equals to b, or it can also happen that b equals to minus b. So basically this criterion is not satisfied, that if of a equals to f of b, then a will be equals to b. There is a second condition, second value also possible, that a equals to minus b. So not injective. So if so how do you check? So if you get that this one is, you understand that not injective and injective, right? And subjectivity, what we have is that if the range is equals to codomain, from the definition you have to check, then it is a subjective function. And bijective is if a function given to you, you find that it is both objective as well as subjective, then it is bijective, no doubt. So that is the function. If we see some examples, maybe. So there are other forms of checking injectivity. It's not that much required at this point. So there are examples of different functions. So what we have is here the first question, first program you see. So this left side set is a domain and the right side sets a codomain. Okay. So the first set is has four numbers given elements in the set 1, 2, 3, 4, and there are few numbers actually, a few variables, few elements attached to the to here to the codomain. So one is connected to one, f of one is D, f of two is B, f of three is C, f of four is A. Okay, so you see that each element in the domain, each input in the domain has exactly one output or related to one image, or we can say one image in the codomain. So that means this is an injective function. Now, there is no extra element in the codomain. So all the elements are connected to any one of the elements in the domain. So the codomain is here, the codomain in this top left diagram, it is same as range. So this function is surjective as well. So as it is injective and surjective, so therefore this is bijective as well. So only if it is both injective and surjective, we have the bijective. The top right diagram, if you see, it is injective because each element is connected to one element in the codomain, right? So 1 is connected to D, 2 is connected related to B, and 3, f of 3 is equals to E. But there is one added element in the codomain which is not an output of any of the elements in the domain, which is C. So the range is not equals to codomain. Therefore, this is not a surjective function. Now, as this is not a surjective function, this is not a bijective function as well. So, if the function is injective and is the connection okay? Internet connection okay? You can hear me?
Yes, sir.
Yeah. So Kunwar Singh told all linear function is injective. Yeah, that can be true, Kunwar. That can be true. Yeah, actually, I mean, we are having some, bad weather, so I was a bit unsure. Sometimes the network connection gets. Anyway, so that is the one way of telling if it is not bijective. That if it is injective but not surjective. The other possible way of happening a not bijective function is that if it is surjective but not injective. That is shown in the bottom left diagram. Okay, so here you can see that we have 1, 2, 3, 4. F of 1 is D, F of 2 is B, F of 3 and 4 both are C. So unique value to an unique input leads to unique output, which is the condition of injectivity. That is not satisfied. Okay, as that is not satisfied in the bottom left diagram, therefore this function is not an injective function, but it is surjective because you see in the codomain, all the codomain values elements are actually in the range. So the range is equals to codomain. So this is a surjective function. But as unique value does not lead to an unique output, unique input does not lead to an unique output. Therefore, it is not injective. So if injective, not surjective, then it is never bijective. If it is not injective but surjective, not bijective. And if you have the fourth option, that is the bottom right diagram, so it is neither injective nor surjective. So you see that this is satisfied that the f of 3 and f of 4 both are equals to C. But there is an added element in the codomain A, which is not in the range. A is not the output of any of the inputs from domain. Therefore, this function is not surjective, and neither it is injective, because f of 3 equals to f of 4, but 3 is not equals to 4. So as it is not injective, not surjective, therefore this is not surjective. So that is the basics of function which is discussed. Apart from that, what is there is I think okay, sorry, I am logged out. Just a minute.
So questions related to finding domain and range of functions.
Yeah. So range, though, you can find out easily. I think that I mean, if you put different values and you can check that what is the exact what is the rate values it is taking out which is coming. Okay, that will be how to calculate the range. Range calculation should be calculated from there. We about domain, we have to, you can see at the in the resources from instructors tab, what you have here is the problem solving kits. So here, just sure. Yeah. So functions, you see. Yeah, so this part we discussed that what is set, what is the domain, what is the codomain, the set into which all the output is constrained to fall. That is called codomain. These are the mathematical definitions. Set of outputs are called range, and so if f of a is equals to b, the input, which is a, is also, there is another term called pre-image. So f of a equals to b, then b is called the image, and a is called the pre-image. The input is called the pre-image. Okay. Now, what we there are, so one way is to find the domain is that from the definition that you either draw a function or you can calculate that this is the range. Then by looking at the function, you want to try to understand or invigilate what is the domain. So some function with a special form which may be difficult to calculate, those domains are given here. So if the function is given under root something, say fx equals to root over g of x here, then for the function fx to be real value, what we must have, so for a function to be real value, the uh, portion with x with the variable that must not be 0, right? So if it is under root something like under root g of x here, so then the g of x part should never be equals to 0. And root over negative term is also not allowed here, as we are not discussing about irrational. So for our case, we will be having g of x is greater than equals to 0. So that will be our domain, that g of x, this is the condition of the domain, that g of x is greater than equals to 0. So basically all positive numbers greater than equals to 0. So starting from 0, all the positive numbers will be in the domain. One is that. Another thing is if we are giving in the numerator denominator format, so g of x divided by h of x, then so the basically the domain is the portion where the function is defined. Okay. So if the under root portion is like not defined, I mean it is negative or something, then the function will not be defined properly. Similarly, if it is a fraction, then the numerator by denominator part, the denominator should not be 0, right? Because if it is 0, then the function is actually numerator divided by 0, which is not a good example, right? Which is leads to undefined. So in that case, for the function to be defined, what we need to have is that the denominator, that is in this case gx by hx, the denominator is to be hx is not equals to 0. So for hx not equals to 0 will be the domain of the function, and x is in the intersection of the, so that is not that much fun, but so basically h of x will not be equals to 0. That is the domain. There are other functions which actually you can either by plotting the function or by looking at different from different aspects, you can see it from a case-to-case basis. Okay. Otherwise, so there is nothing much we can exactly tell at this moment. Okay. So if you have any particular question, maybe we can put in the discourse and we can answer it. Will that be okay? Sure.
Okay, sir.
Yeah, sure. Just put us in the discourse, ping us in the discourse that what is the exact query, and we'll answer. Okay. So that is that. We'll take a 1 minute gap, and then we'll start again. If you guys any doubt or any issue you have, you can ask here. We'll try to solve it. Any questions if you have, 1, 2, 3. We'll try to solve. If possible, we'll solve here. If not possible, we will answer. You just ask us in the discourse and we will answer. Okay.
Excuse me, sir.
Yeah. So if no, no, I mean, yeah, if you wish, you can leave. I mean, we don't have. I mean, nobody has any question. It seems. We'll just discuss the main thing of today's session, which was main focus, the week 3 activity question marks, and then maybe we can leave. I think we have the activity questions here. Yeah. So if you can see my screen. So if you can see, the first question was, if the x-intercept and the y-intercept of the straight line is given, then choose the correct form. So as we can understand, here will be two intercept forms. So intercept or it's only intercept form is required, x by a plus y by b. So x by minus 6 plus y by 7 equals to something. And then from there we have to just multiply, cross multiply maybe, and get the formula. So the first option is correct, 7x minus 6y plus 42 equals to 0. Then the question is the slope of the line 6x minus 2y plus 8 equals to 0. So how do we know the slope? As we know that 6x, so we can just you know write 6x plus 8 equals to 2y. So y equals to mx plus c in that form. If we write 6 by 2 will be equals to 3. So obviously the option B is correct, which is 3. That is done. Then the multiple select questions. So the multiple select question is the general equation of the line is in the form ax plus by plus c equals to 0. Fine. Then choose the correct set of options. So the intercept form is given. Intercept form is x by 10 plus y by 6 equals to 1. Obviously, so from you can just change the fractions from here to there, the numbers, and it will come out. What is the slope intercept form? Slope intercept form means one will be in slope, another will be in intercept. So mx plus c, obviously. So mx plus c seems the most important thing. Once you go to linear regression or something, mx plus c is the only thing in machine learning algorithms. Anyway, so numerical answer type questions. The equation of a line is 4x minus 2y minus 12 equals to 0. In that case, what is the slope of the line? Seems very easy, right? So 4x minus 12 equals to 2y. You can divide by 2 in both the cases. Another just before I forget, another thing is that if you are calculating SSC, the equation which is given, if you can convert it to a much simpler form, you can do that. If it is giving the say, if it is I mean, till the time it is in the same form, should not be much of a problem. But generally we try to give the equation in a simpler form for your calculation. Easy message is we are talking. What is the x-intercept? What is the y-intercept? We understand. Okay. Uh, that is that basically. So from here, nothing much can be done from this question. Uh, then the parallel and perpendicular lines. So we understand if the line 3x plus 5y and 6x plus 10y will be parallel, because you see the coefficients are actually same. 3x plus 5y minus 10 equals to 0, and then maybe 3x plus 5y minus 13 equals to 0, right? Because 6x plus 10y minus 26 can be divided by 2. So therefore 3x plus 5y minus 10 and 3x plus 5y minus 13. Parallel lines. The slopes are all equal. Okay. Then what is there is that perpendicular lines, if their product is minus 1, then it will be perpendicular lines. So if yeah, obviously if one variable is given like k, and if the given lines are parallel, then find the value of k. Right. Similarly, the equation of a line passing through a point perpendicular to the line. Okay, fine. So basically what we have to find is, we have to find the family of the perpendicular lines of the lines perpendicular to 3x plus 4y minus 8, and among those family, which of the line passes through the point 3, 4, that we have to calculate. So you see it is coming 8x minus 6y equals to 0. Similarly, given lines, if two lines are perpendicular, then find the value of the k. That should also be easier. I mean, seems easier as most of you, all of you have done it. So, and the value coming like 9 or something. So it can be in the points also, decimal points also. So whenever you are going to attend quiz 1, okay, please read the instructions carefully. Whatever instructions are given before the exam paper, okay, in the first page of the exam, please, or in the portal, in your case, then you just read the instructions very carefully. Okay, those will be important for your uh, assumptions, for your approximation, what values you can take, you can't take, all those will should be uh, maybe given. Okay? Not should be, but maybe given. We'll try to as much as possible. So if the general form of a line is 3x plus 2y minus 5 equals to 0, then what is the slope? You can calculate. So 3 by, so it will be y equals to minus 3 by 2, right? That is the slope. The point where the given line cuts the x-axis. So what is the x-intercept? That will be 5 by 3 comma 0. Similarly, given the point, choose the correct set of options. Minus 2 comma 1 in the line, minus 3x plus 4y minus 7. So the y-intercept and the distance between 2 points can also be calculated from the formula. Yeah, SSC, as we were talking, if one equation is given, y equals to x plus 1, and a few sets of numbers are given, okay, it can be in points also, decimal points or decimal numbers also. So to find the SSC, or if two equations are given, yes, there it can have uh, the equation, best fitting equations you have to find out. So here you can see all the SSCs are given. So the SSC equals to 40. This is for option B. The SSC value is least, right? The lowest. Therefore, this is the, and this is actually, we can see that it is a best fitting option. So that is our week 3 activity questions. If you guys have any other doubts related to this, we can discuss, or else we can close the session now. Anything you want to say? Okay, if nobody's, you guys want to discuss anything? Yeah, hello. Okay, so if you don't have anything to discuss, maybe we can close the session here.
Thank you, sir.
Yeah, sure.